Hello again. We are continuing our discussion on linear equations. We are going to talk about how to solve an equation where you've got absolute values in that equation. All right, so let's talk about what absolute value means. The absolute value of a number is just how far away it is from zero. Okay, so positive numbers can have an absolute value and negative numbers can have an absolute value. So let's talk about numbers that are, say, 5 units away from 0. There's two of those. 5 is 5 units away from 0, and negative 5 is 5 units away from 0. So both of those have an absolute value of 5. We can say that the absolute value of 5 is 5, and the absolute value of negative 5 is also 5. Okay, so in general, if a number is x units away from 0, then the number is either x or it's negative x. So we're going to use that logic when we are solving absolute value equations, and what that means is we're going to have to split that equation into two separate linear equations and solve them both. Okay, one of those equations is going to be where the inside of the absolute value, those vertical bars, whatever's in there, that's positive. And the other one is going to be where the inside of the absolute value is negative. The reason that we have to do both is because we don't know what the value of the variable is, and since the variable is inside the absolute value symbols, then we don't know whether what's inside those absolute value symbols is positive or negative, so we need to consider both. Okay, so for example, if I have absolute value of x plus 1 equals 3, I don't know whether x plus 1 is positive or negative. All I know is that x plus 1 is 3 units away from 0, so it could be 3 or it could be negative 3. I don't know. So here are my steps. I'm going to do what's called isolating the absolute value. What that means is just get it by itself on one side of the equal sign with everything else on the other side of the equation. Then we're going to split the equation into two equations and solve those separately. So for the first equation that I create, I'm just going to drop the absolute value sign because when you have absolute value of a positive number, you can just drop the absolute value and get the same answer. In the second equation, I'm going to drop the absolute value and change the sign of the other side, implying that what was inside the absolute values is actually negative. All right, so for example, if I have 2 times the absolute value of x plus 3 plus 1 equals 11, I need to get the absolute value of x plus 3 by itself. So that means I need to get rid of that multiplication by 2, and I need to get rid of the addition of 1. So let's remember the order that we do those things in. I'm going to get rid of the plus 1 first, and to do that I'm going to add negative 1 to both sides. So there it is showing up on both sides, that green negative 1, and so the left side is going to be 2 times the absolute value of x plus 3, and the right side is going to be just 10. Now I can divide both sides by 2, and so the left side becomes absolute value of x plus 3, and the right side becomes whatever 10 divided by 2 is, and that is 5. So now I have isolated the absolute value, and I'm ready to split this equation into two equations. Okay, so there it is. The first time I do this, I just drop the absolute values, and I get x plus 3 equals 5. So let's solve that one by subtracting 3 or adding negative 3 to both sides. And if I do that, the left side becomes x, the right side becomes 2. Moving to the other equation, I'm going to drop the absolute values but change the sign of the number on the other side so that x plus 3 is negative 5. Again, I will subtract 3 or add negative 3 from both sides, and I will get negative 8 as my answer. So it looks like I have two solutions to this, x equals 2 and x equals negative 8, but let's check to make sure that those answers are indeed correct. So there's my original equation that I started with. I'm going to start with replacing x with 2. And when I do that, I get 2 times the absolute value of 2 plus 3 plus 1 equals 11. 2 plus 3 is 5. So I change 2 plus 3 to 5. The absolute value of 5 is 5. And then if I simplify 2 times 5, that's 10. And 10 plus 1 is 11. So the x value of 2 actually works. Now let's try the same equation, plugging in negative 8 for x. If I do that, it looks like 2 times the absolute value of negative 8 plus 3 plus 1 equals 11. Well, looking inside the absolute values, negative 8 plus 3, that's negative 5. The absolute value of negative 5 is 5. 2 times 5 is 10, and 10 plus 1 is 11. So that x value works as well. So I actually have two solutions to that absolute value equation, but that doesn't always happen. Here's an example. We have 3 times the absolute value of x plus 1 plus 2 equals 6x plus 11. So first I'm going to get that absolute value by itself. To do that, I need to subtract 2 and then divide by 3 because that's on the left-hand side with the absolute value of x plus 1. So I will add negative 2 to both sides. That will get rid of the plus 2 on the left, and it will change the right-hand side. So now I have 3 times the absolute value of x plus 1 equals 6x plus 9. Dividing by 3 on the left gets rid of that multiplier of 3, and on the right it gives me 2x plus 3. Because 6x divided by 3 is 2x, and 9 divided by 3 is 3. So I have to divide everything by 3. So now I've got x plus 1 in absolute values by itself. On the left, I can look at both equations. So the first equation, I just drop the absolute values. And it looks like this. X plus 1 equals 2x plus 3. Okay? If I subtract x from both sides, I get 1 equals x plus 3. And if I subtract 3 from both sides, I get x equals negative 2. Looking at the other equation, I'm going to drop the absolute values and change the sign of everything that's on the other side. So the 2x becomes negative 2x, the 3 becomes negative 3. Subtract x again, and I just get the 1, and I get negative 3x minus 3 on the other side. Add 3 to both sides, and I get 4 equals negative 3x. And if I divide by negative 3, I get x equals negative 4/3. So again, it looks like I have two solutions, x equals negative 2 and x equals negative 4/3, but one of those solutions is not going to work, as you will see. I have to plug those in to make sure I know which equation of those two works and which one doesn't. Okay, so if I plug in negative 4/3, I get 3 times negative 4/3 plus 1 in absolute values plus 2 equals 6 times negative 4/3 plus 11. Okay, inside the absolute value, I get negative 4/3 plus 1 equals negative 1/3. And on the right, that's 6 times negative 4/3, that equals negative 8. So the absolute value of negative 1/3 on the left is 1/3, and if I simplify the right, negative 8 plus 11 is 3. So now I do 3 times the 1/3 on the left, that is 1, and if I add that to the 2, I do get 3. So the solution of negative 4/3 actually works. Okay. Now let's try the same equation, and we will plug in negative 2. If I plug in negative 2, I get 3 times the absolute value of negative 2 plus 1 plus 2 equals 6 times negative 2 plus 11. Okay. If I look inside the absolute value, the negative 2 plus 1, that equals negative 1. And if I simplify on the right, 6 times negative 2, that's negative 12. Okay. The absolute value of negative 1 is positive 1, so I will change that. I will also simplify the right. Negative 12 plus 11, that is negative 1. So I have 3 times 1 plus 2 equals negative 1. 3 times 1 is 3, and 3 plus 2 is 5. 5 equals negative 1. Well, I know that that's not true. So that means that x equals negative 2 is not a solution because when I plug it in, it does not make a true statement. So I only have one solution to that equation. So sometimes you get both equations or both solutions to work, sometimes you get one solution to work, but you do have to check both solutions for absolute value equations. If you have any questions about this, please let me know, and I will see you tomorrow.